Good day, students. Today the topic is solving exponential equations using logarithms. Okay. There's just a few steps to do this, and the previous assignments will practice those skills to accomplish those steps. Okay, step number one is to simplify the equation as much as you can. So if it's an exponential equation, there should really just be three parts to it. As we already talked about, there's the base, there's the exponent, and there's the output of the exponential equation, which is on the other side of the equation. In homework number 12, we practiced changing the form to exponential. And when you do that, it reads log of what was log of s base q equals r. And the interesting thing about this is now r is isolated on one side of the equal sign. And r was what was the exponent in the previous equation. This is where the variable is going to be. So when you solve for r, or when you evaluate it, your calculator can only handle base 10 or the natural base. So we did the change of base rule, which would read log of s, which is what you previously took the log of, divided by the log of q. And that is what you previously took. That was the previous base of the previous equation. Okay, it is base 10, but you don't need to actually type that into the calculator because that is what the calculator is programmed to do. Okay, let's take a look at a couple examples. Okay, here we have an exponential equation. It's already simplified as much as we can. 3 raised to the x equals 50. Notice that the variable is in the exponent. If I were to use guess and check, I could plug in integers into this and try to figure out what the exponent would have to be. 3 squared is 9, too small. 3 cubed is 27, still too small. 3 to the 4th power is 81. Okay, now it's larger than 50. So I know that the solution to the exponent has to be somewhere between 3 and 4. Okay, because it's already simplified as much as we can, we are going to change the form to log form, as we do in step number 2 in the notes. So it reads log of 50 base 3 equals x. Just rearranging the three parts into a log form using the previous rule. Okay, it's actually solved right now, but to evaluate it, I'm just going to do a simple change of base rule. Log base 10, which is the common base, of 50 divided by log common base 10 again of 3. On the calculator, that would read log of 50. Remember to close the parentheses so that you know that that log is now done. Divided by log of 3. Enter. And I'm going to round my answer to the nearest hundredth place. And it is, as I thought it was going to be, some irrational number between 3 and 4. So I'm going to say x is approximately 3.56. Okay, let's try that again, just doing the same steps. Let you guys take a look at that. Okay. All right. 2 raised to the x equals 1 million. Yeah, this is like saying how many times do I need to double a number to get to 1 million times that original value? Kind of an interesting question. Okay, so I'm going to, it's already simplified. We have the base, the exponent equals the output. Change the form. Log of 1 million base 2 equals the x on the other side now. Okay, change the base rule so that I could type into the calculator. Common base 10, but it'll look like log of 1 million divided by log of 2 base 10, the common base. I will evaluate it on the calculator. Where's that log? There it is. Log of 1 million. If I were to hit enter right now, I bet you that would be 6 because 10 raised to the 6th power would be 1 million. So therefore log of 1 million would bring me back to 6. Anyways, let's continue. Divided by log of 2. Close parentheses for that as well. If you're doing this on the Google calculator, it is the exact same order and the same parentheses, in case you don't have a graphing calculator at home. Okay, there we have it. It is approximately 19.23. All right. Follow those 3 steps to solve exponential equations by changing the form to logs. This is for homework number 15. Have a nice day, guys.